Okay, so here are some right ways and wrong ways of doing this. Okay, your book likes to give these examples. So these are the same exact molecule. If you look at this molecule right here, let me use a different pointer here. This molecule right here is the same as this molecule. And they're kind of showing you a wrong way and a correct way. All right. Well, I'm sorry. So on this one, you have the same number. So people always ask, what happens if you have a big molecule? Notice if I count here, I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I have 7 and 7. It doesn't matter how I count it. So which way is correct? The way that is correct is the one that gives you the more substituents. I think this is a weird rule. I will be honest with you. But that is the rule. That's what the IUPAC convention people decided to say, is that if you are equal, if you have more than one way of counting your maximum carbons, they both have ways of counting 7. Okay? The way that you're going to count it is the one that gives you more substituents. Okay? Because notice if you count on this way, you've got 3 substituents. This way gives you 4 substituents. Notice that there is no other way that will give you 7 carbons. If I go like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I mean, I can spend all day counting them. These are the only 2 ways that I would get 7, and so this is the way that I am going to name it. Okay? So start counting. So I can either have this as 1, this carbon here, or have this carbon as 1. If I have this carbon as 1, my first substituent lands on carbon 2. If I start counting here, my first substituent starts landing on carbon 3. So that means I'm going to start counting on this side. So that's 1, 2, 3, 4, 5, 6, 7. Okay? So at the 2 carbon, I have a methyl group. At the 4 carbon, I have a methyl group. And at the 5 carbon, I have a methyl group. At the 3 carbon, I have an ethyl group. Remember, 2 carbons is ethyl. And then these are all methyl. Okay, so now in naming this, so first of all, naming it, it's a heptane. It's some sort of a heptane. Okay, so I know it's heptane. I've got methyls and I got ethyls. So you have to number and you have to name it alphabetically. So ethyl comes before methyl, so it's going to be 3 ethyl hyphen. Hyphen always goes between letters and numbers. 3 ethyl. Now as far as the methyl groups, I have 1 at 2, I have 1 at 4, and I have 1 at 5. So I need to tell the reader that that's the positions I have all the methyl groups. So I have a 2, a 4, and a 5 methyl, but I have 3 of them, so I have to say trimethyl. All right, everyone kind of knows if there's 2, there's di, tri. If there's 4, it's tetra. All right, 5, we probably won't see more than 5, but we'll just say 5 penta. All right, so this molecule is 3-ethyl 2,4,5 trimethyl heptane. All right, and I'm sure they kind of give you the name of it. When there are 2 longest chains of equal length, use the chain with the greatest number of substituents. That's what we just talked about. Okay, here's kind of a hint. Your publisher does this. I kind of like this. When looking for the longest continuous chain, look to find all the different chains of that length. Often the longest chain with the most substituents is not obvious. Okay, so that means you kind of have to look for them. All right, so here they are numbering it, or they're naming it for you. We already did it, but just to show you, number the longest chain, beginning at the end of the chain nearest the substituent. So we named it correctly. Notice the name of it, 3-ethyl 2,4,5 trimethyl heptane. Okay, and then you have the 3, because you have 3 methyls, it's tri. Okay, here are the names of the alkyl groups. I wish this slide was earlier, but you know, here are we've already talked about this: methyl, ethyl, propyl, butyl, pentyl. All right, 1 carbon chain, 3 carbon chains. Okay, now what happens when you have isomer chains? So notice, so these are the groups hanging off of, so imagine I have a longest chain here, and this group is hanging off of my longest continuous chain. This is called a methyl group. Okay, so imagine I have a long chain. This group is hanging off of it. I got an ethyl group. So imagine I got this long chain. It doesn't matter how many carbons it is. If your 3 carbons are in a row, it's called a propyl group. Okay, now what happens if you have a different isomer of this? Let's say this methyl group is attached to this one. So here's my longest continuous chain right here. Okay, let's imagine that's my longest continuous chain, and these three groups are hanging off of it. Okay, so notice this is not the same structure as these. So this is going to have a different name, and since this is an isomer of the propyl group, it's called isopropyl. So if I have some sort of I'm sure we'll see an example, but if I have some sort of chain hanging off, it's not really important how big it is, and I have this group hanging off of it where I have a CH3, a CH, and a CH3, and this is a substituent, this is called an isopropyl group. So when naming it, it's called isopropyl. All right. Now, alphabetizing, you use the I. I is used when you alphabetize. How I remember it is iso is, because the word is in it, alphabetized. Okay. The reason I'm making a fuss about this is because if you look down here, you have sec and tert. These are not used alphabetically. You use the B in the butyl part. Okay, but on isobutyl, you do use the I. I hate when that does that. Sorry about that. Okay, so that's an isopropyl group. If you have 4 carbon fragments, so imagine my longest continuous chain, how, let's say it's here, and I'm numbering it, 1, 2, 3, 4, whatever, and I have this group hanging off of it as my substituent. It's 4 carbons. That's a butyl group. If it looks like this is called an isobutyl group, where one of the carbons is moved over, but this is still my longest chain. Sec-butyl, this I kind of remember because if you look at the straight chain, and if the biggest chain is now hooked to this carbon, the second carbon of that straight chain, which is what this is, it's on the second carbon, it's called sec-butyl. And then tert-butyl is where you have a carbon with 3 methyl groups hanging off of it. So again, this is my longest chain, and here is a tert-butyl group hanging off of it. We'll see an example. Trust me. Applying the naming rules. Let's see what this chart is. Name the groups attached to the longest chain as alkyl groups. Give the location. Write the alkyl groups in alphabetical order. Same thing. Again, repetition. Repetition is key. This is my longest chain. Okay, where do I start numbering? Look at the molecule. I'm going to start numbering on this side. 1, 2, 3, 4, 5, 6. Okay, why not this side? Because that would be 1, 2, 3, opposed to 1, 2. What's the name of this alkyl group? It's 2 carbons, therefore it's an ethyl group. What's the name of this one? If you said methyl, good job. All right, so now we name it alphabetically. E comes before N, M, sorry. So 4 ethyl. 2 methyl. 4 ethyl, 2 methyl hexane. That would be the name of it. Okay, they're doing it for us. We already did it. Let's just see if we match. All right, our number matches, our substituents match, and our name matches. All right. Another thing I want to talk about is what happens if you have 2 different groups that are equal. All right, meaning, like for example, well, let's say this ethyl group was on the carbon 2. That's not a good example. Let's we already talked about the multiple groups. Here, let's kind of, oops. Like for let's see. Let's say we do there, that molecule. Okay, notice my longest chain here is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh no, I'm sorry, that's not correct. That's not correct. I want to put it right there. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Now we could do this 1, 2, 3, 4, 5, 6, 7, 8, but you'll end up with the same exact name, the same exact compound, so it doesn't really matter how you do it. So that's my main chain right here. That's my main chain. So notice if I start here, 1, 2, 3, 1, 2, 3. Well, I got a tie. So which way do I go? It's pretty obvious. Try to think of what you think the answer is. If you said choose the direction that gives you the alphabetically first substituent, that would be the way you do it. So I have a methyl group here, and I have an ethyl group here. Since I have a tie, I then go alphabetically. Since ethyl comes before methyl, this is the way I'm going to start counting. Okay? So this would be called 3-ethyl, 6-methyl octane. Okay, I don't know if there's a slide on this. There might be a slide. Well, I already taught it to you, so we're already a step ahead. Multiple groups, we just talked about this. If you have more than one group, the same group hanging off of it, you have to use di, tri, tetra, whatever. In this case, it's going to be tri, and you got to use all the numbers. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 5, 7 trimethyl. 2, 5, 7 trimethyl, and since it's 10 carbons, decane. All right, that would be the name of it. 2,5,7 trimethyl decane. Okay? Here's a problem. Give the structure of 4-isopropyl octane and 5-tert-butyl decane. Wow, they just jump you right into this. All right, why don't you put this on pause and see if you can figure out the structure. Put it on pause now. Okay, I assume you put it on pause. I'm going to go through the solved problem. So 5-isopropyl octane. I'm going to write it out, but I'm sure, you know, as I scroll through, it'll give you the answer. So these are usually easier because the name's a structure. So octane, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. On the 4th carbon, 1, 2, 3, 4, you have an isopropyl. As long as you know what isopropyl is, you're fine. Okay, 5-tert-butyl decane. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5. You have a tert-butyl group. So that's what you should have. If you have that, good job. All right, now notice I'm doing the line drawings, but here they are, you know, just in regular, straight out, the carbons and the hydrogens. All right. Name this compound. Put it on pause and name it. Welcome back. If you didn't know you had to shut it off now, and then come back. So look for your longest chain. My goodness, there's so many possible ways I can start. This, I don't know, this looks like maybe the biggest. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it looks like 8 is the longest. Okay? And it looks like this. Now you might be asking, why didn't I include this carbon? Why this one? It's the same molecule. It doesn't matter which way you do it, because remember you have free rotation around here. So that's the 8. And then the next thing is, we have to start numbering this correctly. So if I start here, second carbon has 2 substituents, or that's my substituent. Here, 1, 2, 3 carbons, so I'm going to number here. 1, 2, 3, 4, 5, 6, 7, 8. I've got a methyl, a methyl, a methyl, a methyl, 4 methyls. I have 2 of them at the 2 carbon. Now this is not a rule we talked about, but kind of is. If you have 2 of the same substituents on the same number, you still have to write that number for both of them. So this is going to be some sort of a 2, 2, 3, 6 tetramethyl. Okay? I know it sounds redundant, but you need to do this because maybe that methyl was on the 4 carbon. So it'd be 2, 3, 4, 6. How do you know you have 2 of them on the same 2s? So that's why you have to do that. If you just say 2, 3, 6 tetramethyl, well, do you have both of them on the 2? Do you have both of them on the 3? Do you have both of them on the 6? Where is that 4th methyl group? You need to tell them where all 4 methyl groups are. And then we have this one. What was the name of this one? Notice it's 3 carbons, so it's some sort of a propyl. It's not hooked to the first one for a straight chain. It's the isomer. Therefore, it's isopropyl. Good. Okay, and this is 4-isopropyl. Now we got to alphabetize. Remember, iso is used alphabetically, but tetra is not. So we're going to use the M. So here we have I, here we have M. So I obviously comes before M. So this is going to be called, I wish I had room here. I'll just put it all down here. 4 iso propyl 2 2 3 6 tetra methyl octane. What do you guys think of that? Pretty sweet. That name is almost as long as the structure. Okay, solution. We're going to go through the solution, but I think you pretty much did it. Longest continuous chain has 8, so it's an octane. There's your substituents, just like what we said. Notice they went a different way. You see how they went this way? I'm glad they did that, because it's to show you it's the same exact compound. It doesn't matter which way you go. Even if you included that one in your longest chain, you still get the same compound. So I'm glad they did that to show you, prove to you that it is the same compound. Okay? When substituents are, okay, we've already talked about this, but let's go over it again. When substituents are alphabetized, iso is used, okay, but the hyphenated prefixes are not. Thus, isobutyl is alphabetized with I, but N-butyl, tert-butyl, sec-butyl, whatever you use, you do not use those, you use the B.